All right, so let's talk about the phosphocreatine system. This is the body's fastest way to regenerate energy, and this system plays a key role in high intensity, short duration activities like sprinting and lifting weights. So let's break this down for you. What is the phosphocreatine system? It's the body's emergency ATP reserve. So, just like we learned in seventh grade biology, ATP is the energy currency of the cell. So, ATP is also known as adenosine triphosphate. It's the primary energy source for all cellular functions. The PCR system rapidly replenishes ATP, which makes it essential for short bursts of high energy output. So, why is ATP important? It's necessary for every muscle contraction, every brain signal, and every heartbeat. When ATP breaks down into ADP and inorganic phosphate, it releases energy into the cell. So ATP stores in muscles are limited. It only lasts about 2 seconds and it must rapidly be replenished. So this is where the phosphocreatine system steps in, and the PCR system steps in by donating a phosphate group to ADP, quickly restoring ATP levels, allowing muscles to sustain high power output for about 10 to 15 seconds. So think about activities like sprinting, heavy lifting, explosive movements. These all rely heavily on the PCR system. Once PCR stores are depleted, the body then transitions into anaerobic glycolysis, which is a completely different energy system, and then it eventually goes into the oxidative system for longer duration energy production. So, why does this matter? The PCR system is the fastest way to regenerate ATP, which makes it critical for short term intense efforts, sprinting and weightlifting. Understanding the system helps optimize training and performance in high intensity activities. So, as you can see here, ATP is already stored in the muscle tissue, it's already stored in the body. Once that's depleted, the ATP slash PCR system kicks in and will restore that energy for about 10 to 15 seconds. Once that's depleted, then the body will kick into anaerobic glycolysis. Once that's depleted, it'll then kick into the oxidative energy system. Okay, so now let's break this down just a little bit further. First, phosphocreatine, also known as PCR, donates a phosphate group to ADP, instantly regenerating ATP. Second, this reaction is catalyzed by an enzyme called creatine kinase, which speeds up the process. Finally, this entire reaction happens in milliseconds, making the PCR system the fastest ATP resynthesis system in the body. So there's no waiting around, it's immediate energy recovery. On the left, in a resting muscle, we have ATP and creatine combining to form phosphocreatine, which acts as a stored energy source. On the left, in resting muscle, we have ATP combining to form. On the left, in the resting muscle, we have ATP combining with creatine to form phosphocreatine, which acts as a stored energy source. When muscles become active, PCR quickly breaks down and donates its phosphate group to ADP, which reforms ATP and provides energy for muscle contraction. So this system is absolutely critical for high intensity, short duration movements. However, there's a catch. Your PCR stores are limited and can only last about 10 to 15 seconds of maximal effort before depletion. That's why for longer activities, your body needs to rely on other energy systems like glycolysis and oxidative phosphorylation. So that's why athletes and weightlifters often supplement with creatine, because it helps increase PCR stores and gives them a slight edge in high intensity performance. And this is exactly why you should supplement with creatine as well. Okay, so now where does creatine come into play in terms of how it can supercharge the PCR system? Number one, it increases PCR storage. So it increases the amount of phosphocreatine stores in the muscle tissue by 20 to 40%. Higher PCR levels means more ATP regeneration, which means higher sustained performance. So the benefits of an enhanced PCR system: delayed fatigue, which means you can do more reps, more sprints, and generate more power. It boosts recovery, so you have a faster replenishment of PCR after exertion. It enhances cognitive function, so ATP supports the brain energy metabolism, and it supports aging and longevity because it protects against ATP decline in muscles and brain. So creatine is actually more of a holistic supplement that will also improve longevity, cognitive function, recovery, and delay fatigue, while also adding mass to muscles and increasing your power output while you can have a higher level of sustained performance. There's really no reason not to take creatine. So, of course, creatine monohydrate is one of the most researched and effective supplements in the performance, muscle growth, cognitive function, and longevity space. What is creatine? It's a naturally occurring compound. It's synthesized in the liver, believe it or not, in the liver, kidneys, and pancreas from three amino acids, arginine, glycine, and methionine. So it's stored primarily in skeletal muscle, about 95% of it, in both free and phosphorylated phosphocreatine forms. In terms of metabolic pathway, what you really need to know is storage and transport. It's transported into muscles by the sodium-dependent creatine transporter, and then once inside, it's phosphorylated by a creatine kinase to form phosphocreatine, like we just said, and it acts as a rapid ATP buffer. So once that initial storage of ATP declines, creatine will donate a free phosphate to the ADP, making ATP, and their cycle can continue reoccurring over and over again. So creatine really does play a pivotal role in cellular metabolism, particularly in tissues with high energy demands like skeletal muscle, the brain, and cardiac tissue such as your heart. So kind of going into more detail on how creatine can support mitochondrial bioenergetics in multiple different ways. Obviously, creatine and mitochondrial ATP production is helpful to understand. So mitochondria generate ATP through oxidative phosphorylation within the electron transport chain. So creatine enhances mitochondrial function by increasing mitochondrial ATP synthesis efficiency, again by acting as a buffer, and it reduces reactive oxygen species production, which prevents oxidative damage, which also enhances your ability to stave longevity or to stave aging. The phosphocreatine shuttle is a key energy transportation system where ATP is produced in mitochondria, but it needs to reach areas of high energy demand like your muscle fibers and your neurons. And the phosphocreatine shuttle transfers energy efficiently by generating PCR in mitochondria, and then PCR diffuses into the cytosol of the cell, and then PCR rapidly converts ADP to ATP, like we said, at the myofibrils, which are where muscle contractions actually occur, or synapses, which is where your neurons will fire. So creatine is recycled back into mitochondria for rephosphorylation, and the cycle continues. So improving ATP transport and sustained muscle contraction and cognitive function, and enhancing mitochondrial ATP production increases cellular energy availability. So creatine will also actually give you more energy, quite literally. Okay, so let's also talk about creatine's role in brain bioenergetics, also known as cognitive energy pathways, neurological performance, whatever you want to call it. It indirectly optimizes glucose metabolism, affecting both anaerobic and aerobic energy pathways. So creatine actually supports cognitive function and enhances neuroprotective effects. The brain has high ATP demand for neurotransmission, synaptic plasticity, and cognition, and neuronal phosphocreatine stores help sustain ATP production for dopamine and glutamate release, which is essential for learning and memory, neuronal firing and signal transduction, and reducing mental fatigue for cognitively demanding tasks. So creatine essentially does the same thing for your brain that it does for your muscles by giving it an energy system buffer and allowing it to have higher levels of sustained energy and delaying brain fatigue. The brain is actually acting as a muscle because it has to fire. A neuronal fire is also like a muscle contraction. So it also protects against neurological disorders. Creatine acts as an antioxidant, reducing oxidative stress and mitochondrial dysfunction in traumatic brain injury, Alzheimer's, and Parkinson's. There's recent research showing how creatine supplementation after concussion can actually dramatically shorten the timeline to recovery, so it really does have a huge impact on cognitive performance. And then in hypoxia, which is low oxygen, creatine preserves ATP by slowing energy depletion. So it improves mental performance, cognitive resilience, and reduces neurodegeneration risk by stabilizing ATP levels in the brain. So a very common question and something that should be addressed is, when you start supplementing with creatine, what can you expect in terms of how it will affect your body composition? So creatine supplementation actually enhances muscle mass. It reduces fat mass indirectly because you have higher levels of energy availability, which means you can burn more calories and reduce your fat, and then also improves overall body composition. So it increases muscle mass and strength by intracellular water retention, enhances muscle protein synthesis, and obviously increases your resistance to fatigue, which allows for higher training volume. The initial weight gain from muscle hydration, which is what creatine actually causes, is about 2 to 3 to even 4 pounds, maybe even 5 pounds if you have high levels of muscle mass within the first week or so, because creatine is signaling for the muscles to actually retain more water. So it's intracellular water retention, which is actually a good thing. It's hydrating muscle tissues, quite literally. You will gain weight, but it will be within the muscle tissues. If anything, it's actually going to enhance your appearance because you will have fuller, denser looking muscles. Muscle protein synthesis, which is the rate at which the muscles will use protein to build up tissue and repair tissue. Creatine enhances myonuclear addition and satellite cell activation, which are the components for muscle tissue repairing itself. And then again, resistance to fatigue, allowing for higher training volume, which leads to greater hypertrophy, aka muscle growth over time. Creatine reduces fat indirectly. So since you have more energy availability, it will increase your resting energy expenditure because it's going to increase your muscle mass quite literally, like we said with water retention. And muscle is metabolically active, so it will increase your daily caloric burn. It enhances training and performance, so higher intensity workouts means greater fat oxidation, and it enhances insulin sensitivity and glucose uptake through the GLUT4 transporter, which enhances muscle glycogen storage and therefore reduces the chance that your body will store glucose in the bloodstream as triglycerides, aka fat. So creatine quite literally tells your body to store glucose into the muscle tissues instead of as fat, and increases your training performance because of more energy. And then in terms of muscle definition and fullness, which we touched on a little bit, creatine increases intracellular water retention, so the muscles appear more full and well defined. I personally notice quite a difference when I stop taking creatine, which I hate because I look and feel flat. And it's not water bloating, it's intracellular, so there's no subcutaneous water retention. So you should not look any less lean. In fact, you should look better and more toned once you start taking. So expected changes with creatine supplementation, since I'm sure quite a few of you, after watching this series of videos on the PCR system and creatine, will probably start taking creatine, as you should. Everybody should take creatine. Man, woman, kids, it's safe for everybody. Just take it. I promise you it's going to make a huge difference. But what you can expect, time frame within 0 to 7 days, you will expect your body weight to actually go up due to muscle hydration. Don't panic. It's okay. 2 to 4 weeks, you'll definitely notice strength and power output because of faster ATP regeneration, because at that point, phosphocreatine stores in the muscle tissues are nearly fully saturated, and you can expect 20 to 40% greater phosphocreatine storage in the muscle tissue, which translates directly to training performance. 4 to 8 weeks, you will definitely have an increase in lean mass via hypertrophy and improved training capacity. And 8 weeks plus, you will start to notice greater fat oxidation. Fat mass will actually decrease, your metabolism will be enhanced, and your training performance will be enhanced even further, which will allow you to burn more fat. So optimal dosage, question that's very common. People often talk about loading creatine, which just basically means taking higher doses within the first 2 weeks or so to fully saturate the muscle tissues, and then tapering off to about 5 grams a day. But in my personal opinion, I'm actually going to recommend that loading is not necessary because it's okay. There's no time constraint on this at all. Loading will often give people like the feeling of bloating because 20 grams of creatine is quite a bit for somebody who has never taken it before or who's just starting to take it again. So my personal recommendation is to keep it super simple, 5 grams a day minimum for everybody, males and females and teenagers, athletes and non-athletes, doesn't matter, 5 grams a day minimum. And then if you have more muscle mass for your size, you can go up to 10 grams a day. It can benefit those who are larger individuals, like bigger athletic frames, over 6 foot, males typically with higher muscle mass. I personally take 10 grams a day. I will split it up into 2 doses. I will do one in the morning with electrolytes, and then I will do one post-workout with a smoothie or a shake, or I'll just slam it dry and suck down some water with it. So the best timing for creatine ideally is post-workout, but truthfully, it doesn't matter. Once your muscle tissues are fully saturated with creatine, it's more important to take it every single day instead of taking it at a certain time of day. So mix it with water, electrolytes, or put it into like a smoothie. It's flavorless. I like creatine that's flavorless. And really, it's just best to take it every single day, and you'll notice quite a big difference. In terms of creatine's effects on glycolysis and glucose metabolism, this is really important to understand, especially in terms of your increasing insulin sensitivity and enhancing your body's ability to clear lactate. So high PCR levels, phosphocreatine levels, reduce dependence on anaerobic glycolysis because you have an energy buffer in that first bioenergetic pathway, which is the phosphocreatine system. So it actually extends and buffers that energy system so you can rely less on the next energy system, and it helps buffer intracellular acidity, with hydrogen protons. So it prevents excessive lactate buildup and it delays muscle fatigue. So quite literally, creatine will stave off that feeling and that sensation of having burning muscle tissue when you do high performance activities. Creatine can also increase GLUT4 or glucose transporter expression, which improves muscle glucose uptake and insulin sensitivity. So GLUT4 is what really determines your muscle's ability to essentially take glucose out of the bloodstream and store it as glycogen in the muscle tissue. And when your body is less efficient at doing this, that is a part of what we call insulin insensitivity. So this is an aspect of being obese, being overweight, having some sort of diabetes. Creatine can actually help enhance your insulin sensitivity because it increases GLUT4 expression. So creatine, again, it enhances glucose uptake, and glucose is stored as glycogen in the muscles, which is also used for energy. It increases energy availability in both the muscle and the brain. And then it reduces lactate accumulation because it helps buffer the intracellular acidity through hydrogen proton ions, which prevents excessive lactate buildup. So it actually delays fatigue and enhances recovery. From this research here, you can see pre-creatine consumption, post-creatine consumption, 3 weeks and 10 weeks after. Black bars are GLUT4 activity. So if you take creatine as soon as, like literally as soon as 3 weeks, even less perhaps, you will have increased GLUT4 activity, which means you will have enhanced insulin sensitivity. So if you're somebody who struggles with high blood sugar or some sort of diabetes, creatine can actually help. I'm not going to say it's correcting it, but it can actually help to increase your insulin sensitivity, which will enhance your body's ability to process sugar in the bloodstream and store it properly into muscle tissue.